In Manim, the objects that can be displayed on the screen are called MObjects, or mathematical objects. MObjects is the parent class, and from this many types descend. In this introductory course we are going to study only three: MObjects, MObjects, and groups. The MObjects are the most interesting and most used in Manim, since they are the most flexible. MObjects are, in essence, Bezier curves. Bezier curves allow us to represent complex curves using polynomials. If you have used any vector editing software, such as Inkscape, surely you have already used them without knowing it. MObjects are, in essence, a matrix of pixels. In this basic course we will not use this MObject in this way, but to import images. We will see that in Chapter 6. It is important to note that MObjects are defined using pixel arrays while MObjects are defined with Bezier curves. This difference is important to understand groups and vgroups. Groups are containers for MObjects. We generally use them to arrange or style a set of MObjects more quickly. We will study them in more depth in Chapter 7. While group can be a container of any type of MObject, in a vgroup you can only put MObjects or descendants of MObjects, like texts or SVGs. If you try to put an MObject in a vgroup, then Manim will throw you an error, since MObject is not a descendant of MObject. To avoid confusion with pronunciation, let's just call MObjects as objects. We will call the MObjects simply curves, and the MObjects we will call images, since that will be their main function in the basic and intermediate course. In the advanced Manim course we will learn to manipulate the pixels of MObjects, either to apply filters to them or to create our own images, such as fractals. To add an object to the screen instantly we can use the add method. To add a pause we can use the wait method. As an argument it receives the duration of the pause in seconds. By default, the length of the pause is 1 second. Pro tip: in your animations you are going to have many pauses, and it is a good idea to create several types of pauses. I recommend creating 4 types of pauses: small pause, pause, medium pause, and long pause. These pauses will have their own duration depending on the context of your animation. A good practice is to always put a small pause at the end of your entire project, since if you don't, the last animation will not be 100% complete. We will study the why of this later. Once we have understood the basics of MObject we can get into animations. There are 2 types of animations: play animations and updaters. As you can imagine, play animations always go within the scene.play method, and are divided into 2 categories: class animations and method animations. Although, being strict, method animations are nothing more than a subtype of class animations, only with a friendlier syntax. On the other hand, there are the updaters, which are basically functions that are applied to each frame of the animation, and can also be used as class animation if you want. In the same way, we can convert class animations into updaters, but we will see that in the intermediate course. There are 3 types of updaters: the simple ones, the alpha type, and the DT type. In this course we will only study the simple ones. We will study class animations first, as they are the simplest to use. There can be 1 or more class animations within the scene.play method, although there are some limitations that we will study later. All class animations are descendants of the abstract class animation, and there are 3 important attributes that are very useful when using class animations. 1. Runtime. It is the duration of each animation. In case of having several class animations in the play method you can specify the duration of each one. However, if you want all animations within the same play method to last the same, you can add the runtime as an extra argument to the play method. In case you have defined the runtime both in the animation class and in the play method, Manim will always obey the runtime of the animation class. 2. Rate func. It is the function that indicates the behavior of the animation. There are already several defined rate functions, and we will study them in depth in Chapter 5. The same rules apply to runtime, that is, you can define a rate function to each animation or to the entire scene.play method, and Manim will take as priority the one that is explicitly defined in the animation class. 3. Remove. This attribute receives a boolean. If it is true, then the object associated with the animation will be removed from the screen at the end of the animation. Keep in mind that, although all class animations can receive the 3 arguments mentioned above, each class animation receives its own arguments. There are some class animations that simply receive an object to animate it. There are others that use 2 objects to be able to function. This can be overwhelming for the student, as it can be confusing where to start studying animations, so in this course we have grouped class animations into 4 types. 1. Creation animations. They add an object to the screen. 2. Indication animations. They help to identify an object on the screen. They are actually a fusion of the other 3 animations. 3. Transformation animations. They modify the shape or position of an object. 4. Animations to remove. They remove an object from the screen. This last type is the one that usually has the remover argument set to true. As an exercise, you can consult the official documentation to learn about some animations. We are not going to get too deep into this topic yet, as we need to learn more about MObjects. But don't worry, we'll cover this topic in depth later in Chapter 13. For now, we will only use simple animations. Thus we end Chapter 1 of this basic course. In the next chapter we will see the generalities of MObjects and VMObjects, in addition to learning a little more about class animations. See you in the next chapter.